So we're going to factor when A is not 1 and there's not a GCF. There's lots of ways and lots of different things that teachers have taught this. I have found that I like what I call Big Star. I've also seen it called the snowflake method and lots of other, the asterisk method as well. But the idea being that we're going to take our X, which we use as a diamond, and when we're doing A is 1, I think we call it a diamond method as well. So like I said, tons of options, but we are going to add a line. Now, you can also use this when A is 1. It just seems a little not as useful. But if one process is important to you to be able to do all of them, this is the process that will work for both, because our other process will not work when A is not 1. And again, when I reference A, I'm talking about our leading coefficient, the coefficient in the front of the highest variable with the highest exponent. If it is not 1, then you cannot use just the diamond method with an ACB chart like we've done in the past. Now, at the top, we're going to put A times C. The bottom is going to be B, and each of the upper corners is A times X, and then our factors, and usually you see PQ is one of the way they notate those, but nonetheless, it's the two numbers that multiply to give us what's at the top of our diamond, and then add or subtract to give us what's at the bottom. So A is 5, B is 12, and C is 4. We're going to disregard our m squared and m's at the moment. So A times C is 5 times 4, and 5 times 4 is going to give me 20, and it's a positive 20. And then our B value is a positive 12. A is 5, so 5x, and in this case it should be an m, but for my notation of my handwriting, I'm going to do 5x, 5x. Now, what we have to decide is what two numbers can I multiply together to get 20 that add together to get 12. So this is still exactly the same as our diamond method. What multiplies to get 20 adds to give us 12, or adds or subtracts, so there's some. 10 times 2 gives me 20, and 10 plus 2 gives me 12. Now, hear me out. This is not a fraction. We are completely cheating the system and pretending. This is not a fraction, so it doesn't ever reduce where something goes away completely. There has to be a space holder. So there has to be a top and there has to be a bottom, but we need it in the simplest form. So like 5 over 10 can indeed be reduced to 1 over 2. The x stays. So it's 1x over 2. If we look at 5 over 2, it cannot be reduced. So these are going to fall down into our two factors. So we're going to have x, or 1x plus 2, and then 5x plus 2. These are our factors. To check this, you want to multiply them back together, or use Desmos or your calculator and type in your original equation and your factors and see them graph on top of each other. So these are the factors. If it says factor, you're done. If it says solve, we have to set these equal to 0 and solve for our values of x. And those values of x are the solutions, the x-intercepts, roots, lots of names for those. So that 2 is positive as it moves across the equal mark. So remember, a great divide, when it crosses that, we have to do inverse. So minus 2 minus 2. So x equals a negative 2. Positive 2 again. So we're going to subtract 2, subtract 2. Don't lose our 5x. So 5x equals a negative 2. 5 and x is 5 times x. So the inverse of multiplication, or times, is going to be division. So x equals a negative 2 over 5. So our solution set is going to be a negative 2 and a negative 2 over 5. So those are the two x-intercepts, roots, zeros after you factor. You cannot solve unless you factor. But factoring is the first thing we have to do always. So we're going to do it again. All right. Big, ugly numbers over here. 5 and 42. It's not good. So we're going to do our big star, or asterisk, or a snowflake. It's all different. Again, if you Google ways to factor, they may not use this way because there's a gazillion ways to factor when A is not 1. So A times C on the top, B on the bottom, AX in the left corner, AX in the right corner. Our factors are going to go in the bottom. So from here, you can at least fill in everything with the factors, all of you, even if you're not good at factoring. In this case, we know that A is 5, so A equals 5. And then B is negative 23, so A equals 5, B equals a negative 23, and C equals a negative 42. So A times C, so the first term times the last term, so that's 5 times a negative 42 is going to give me a negative 210. And then B at the bottom is a negative 23. A is 5, so it's going to be 5x and 5x. You have no reason not to be able to do that much. That is not anything magically new. It's a matter of just remembering what goes where. So from this point forward, anytime you are factoring when A is not 1, you have to have this written down. You will not get any further than this if you don't at least go this far. So from here, we're going to look at what did we multiply together to get 210 to get 23. So in our TI-83s and 84s, if we put 210 divided by x in our y equals and then hit second graph, because this is going to have a lot of factors. So 3 and 70, 5 and 42, 6 and 35, 7 and 30, and then we have 10 and 21. Let's see if we get any more. 14 and 15, and then it repeats the opposite way. So that's as high as we're going to go. 14 and 15 are not going to ever combine to give me 23. 10 and 21 would give us 31 or 11 if we subtracted them. Now, 7 and 30 looks good. 7 and 30 will work because if I subtract 7 from 30, I get 23. And one of them needs to be negative because I need to multiply those together to get a negative 210. My B is negative, so my largest factor is going to also be negative. So again, not a fraction, but we are going to pretend like this is a fraction and reduce. Nothing goes away. We have to have a space holder. So 5, it will go into both 5 and 30. So we'll go 5 one time, x stays, so it's 1x. And 5 goes into negative 30 a negative 6 times. So it's 1x over negative 6. 5 and 7 do not reduce. They're both prime numbers. So we're going to open up our parentheses. And we're going to take our first one, which is that 1x, that's x, and then a negative 6, and then 5x with a positive 7. And again, we can multiply these back together by box, FOIL, distributive property, whichever one of those you decided was your favorite to check it. And then make sure it's right. So x times 5x is going to give me 5x squared. X times 7 gives me 7x. Negative 6 times 5x is going to give me a negative 30x. And negative 6 times 7 is going to give me a negative 42. Combine our like terms in the middle. So we have 5x squared, which looks good up here. 7 minus 30 is going to give me a negative 23x and then minus 42. Again, it is in, and if you do delta math, make sure you use the right variables. For my handwriting, I'm using x so you can see what's going on. But do not change the variable in delta math or they will absolutely count it wrong. So just be aware. And then again, this is factors, not solved. You would have to set these both equal to 0 and solve for your solutions, roots, zeros, and x-intercepts. Now, as I've said a couple of times before, but I wanted to make sure we hit this off with the focal point, and that's being able to factor when A is not 1 and there's not a GCF. Every time you walk up to a quadratic that has a number in the front instead of 1, you want to think GCF. So think GCF first. So can I take a 7, a 48, and a 36? They have any number in common to pull out a GCF. No matter what, always check when the front number is not 1 if you can GCF. In this case, you cannot. So again, we're going to take our big star, our line in the middle. AC goes on top. AX goes in the corners. And then B goes in the bottom. Again, our A value in this case is 7. Our B value is 48. And our C value is 36. So B is 48. So 48 is going to go in the bottom. A times C, so 7 times 36, another kind of fun number maybe. 7 times 36 is 252. It is a positive. A is 7, so it's going to be 7x, 7x. I'm going to, again, kind of shorten the trip here. I'm going to do 252 divided by x, second graph, because that's a bunch of them. And we're looking for a set that's going to give me 48. And no kidding, there it is. So 6 and 42 will give me 48. You may want to look around a minute and just make sure that's it. Don't jump on the first one there. After 14, we can maybe see if 16 is 1. It's not. 17. And then we're back to the 18, 14. So we've hit all the combinations. We just have to change up the positive negatives from that point. So 6 and 42 will add to give me 48. So we're going to put 6 and 42. And it doesn't matter where you put it, in the first or the back, as long as you have a pattern that works for you. B is positive and our multiplication. So the sum is positive and the product is positive. So both of these are going to stay positive. We're going to look at this 7 and this 6. It cannot reduce because 7 is odd and 6 is even. So it's good to go. Then look at your 7 and 42. Again, I cannot say it enough. It is not a fraction. We are just using this to clean up. 7 is divisible by 7, and that will give me a 1. And 42 is divisible by 7, and that will give me a 6. Hold on to your X. Again, nothing goes away. You're just simplifying. And then it's going to fall down into its two factors. And by fall down, I mean like fall over. So it's going to be 7x plus 6, and then x plus 6. Again, if we multiply it back together, and you can either do your FOIL method or your box method. So 7x, 6x, and 6. 7x times x is 7x squared. 6 times x is 6x. 7x times 6 is going to be 42x, and 6 times 6 is 36. Pull out our like terms, so 7x squared plus 48x plus 36, and that is where we started. Again, if it happens to be calculator active, you can take your factors, because these are our factors, plug them in, and then also plug in the equation that you were given, and it should graph directly on top of each other. All right, so number 10, 5, 27, and 28. We want to think GCF first. 5 is a prime number, so the only option is 1 or 5, and 1 isn't really going to help anything and make anything better. So that means we're just going to get straight into big star. So again, it's going to be another really large number at the top. The numbers are not always this large, but doesn't hurt anything, especially if you have a calculator. You can also do the AC divided by X in your Desmos. You would just then type it in this case, 5 times 28, because A is 5, B is 27, I'm sorry, negative 27, C is 28. So AC goes on top, and that's 5 times 28. So 5 times 28, 140. So you can type in 140 divided by X in your Desmos, and then go over to the gear up at the top where you put in your equations, and then request a table from that function, and it will give you a table. And you can just type in 1 in the X, 2, 3, 4, and just keep going until you get all the whole numbers. And like I said, until they repeat again. B goes in the bottom, which is negative 27. So this is B. AX, AX. So that's A, which is 5 with an X, 5 with an X. And now we're looking for the factors of 140 that are going to add or subtract to give me 27. So 140 divided by X, second graph. I have 4 and 35, 5 and 28, 20 and 7 looks really good. 10 and 14, 2 and 70 should be up there as well. And 1 and 140. So it looks like it's going to be 20 and 7. So 20 and 7. They need to come together as a negative as far as a sum, and then they have to multiply to be a positive. So when B is negative, the largest one is always going to be negative for sure. You just have to decide if the second one is going to remain positive or remain negative. So in this case, they're both negative because that would give me the sum of a negative 27, and they would multiply together to give me that the positive 40, because a negative times a negative gives us a positive. So we're going to look at this not fraction, see if it can reduce. 5 goes into 5. 5 goes into negative 20 and negative 4 times. And remember, we want to hold on to that X. Then 5 and negative 7 do not, because 5 and 7 are prime numbers. So it's going to be 5x minus 4 and 5x minus 7. And again, multiply those together for the sake of the time of this video, not using up too much of your time. You do want to check and make sure that it is correct. If it was a multiple choice question, you can always work backwards as well. But always want to check, whether it be by foiling, box method, distributive property, or putting in the calculator and seeing this graph on top of that. Now, this is A is 1. These should be really simple, but just to show you how the big star actually works for those as well. Same idea. So AC goes on the top, same thing. So A times C, B, A times X, A times X. So A is 1, B is 3, and C is 2. So A times C is going to be 2, because 1 times 2 is 2. And then B is 3, 1x, 1x. So I want to know, what did I multiply together to get 2, that add or subtract together to get 3? So that's going to be 2 and 1. And in this case, they're both positive because that gives me a positive product, and add them together gives me a positive 3. Look at your not fraction. Because there's a 1 on the top, you can't reduce. It'll never reduce. But again, they fall over, and it's going to be x plus 2 because that's a positive 2. And then x plus 1 from our not fraction on the right-hand side. So it works exactly the same. We just added a line. And again, the check to see if it is going to reduce is probably never going to be a thing. Actually, it is never going to be a thing when A is 1, because that top number will always be 1. So to fill this in, A times C, so A is 1, B is a negative 8, and C is 16. So A times C is 1 times 16, which will give me 16. B is a negative 8. AX is going to be 1x, 1x. What numbers did I multiply together to get 16 that will add or subtract from each other to give me an 8? And in this case, they have to be a negative 8. So hopefully we know that's 4 and 4. And if you need to, you can also make your table over here. So our factors of 16 are 1 and 16, 2 and 8, 4 and 4, 5, 6, 7, 8. And then we run back into that 2 and 8 situation. 1 and 16 gives me 17 and 15. 2 and 8 gives me 10 or 6. 4 and 4 does give me 8. But they need to both be negative because I need to multiply them together to get me a positive 16 and then add them together to leave me with a negative 8. From here, again, you're going to look at your not fraction. 1's on the top, so it's not going to reduce, but you still want to look at it that way if you're going to choose this method for all of them. It's going to fall down, so x minus 4, and then x minus 4. Now, if it's written twice, you're very rarely going to ever see it written in this form because it's the same thing, which is x minus 4 squared. Remember, do not distribute that square in because that x and 4 are attached by subtraction. And that's not one of the exponential rules where we can distribute that 2 on the inside. When we were distributing 2 on the inside, it was multiplication and division inside the parentheses. This is minus because this squared means it's written twice. Both of these are correct notation. This is going to be your best answer. Now, again, this is factors or factored. If we want to solve, since this is our last problem, we're going to set x minus 4 equals 0, and we don't have to do it again because it's going to give us the same answer. We're going to move that negative 4 by adding to both sides, and x is going to equal to positive 4. So the solution, the roots, the 0, and the x-intercept, so where it crosses the x-axis, is that x equals 4. The x minus 4 times x minus 4, or x minus 4 squared, is your factors. All right, guys, great job.